we can have grid lines. I just got why it was stopping, because somehow for this program escape button was equal as stop recording. I changed that, so we should be fine. Now we can go ahead and make grid. So go back to StratoCalc, and what we want is that the strata grid files, and we can do the same as define strata grids auto run. So have that in mind, that right now instead of elevation we want thickness grid files. Then based on thickness we can define where to have them on. So we go to define strata grid auto run, and first thing it asks if we have fault lines. We don't have any. Right click or click enter. Next it asks for drill holes. Select all the drill holes and click enter. If we have any inclusion, this is the inclusion area. Right click, and then if we have any exclusion, we don't have any, so right click again. So we have it here. We from here, what we want is to add the layers. So click on add, and then range of elevation is from 0.01 to 20,000. Then we can choose a strata. So we want both overburden and seam, cold seam. So we can select both of them, click drag, click OK, and they are in separate grids. Now instead of bottom elevation, we select thickness based on feet. So be careful not to choose inches. So we have the first one, click OK. Next we want grid position, so click on set grid position. We want to pick, so select bottom corner, go to top corner, and make sure to choose dimensions of a cell, and 50 by 50 should be good enough for this area. I repeat, for your project or for any other different project that you are making grids, you should run different scenarios to make sure which is the best grid set. Default of the program is 50 by 50, and we go with that, so click OK. So now you see that number of grid cells in each direction is about 569 in X direction and 474 Y direction, which is a good amount. Next is we want to choose grid file name, so it's naming it jawbone overburden thickness grid. So you can select it in surfaces file. And name it OB, same, jawbone overburden THK, which is thickness, and save. Alright, so next is to define modeling method. So to practice, we can model this thickness grid based on different interpolation methods. So first I try inverse distance of search radius of 10,000, and maximum samples is 20, and I don't change mean and max in quadrants. Then go ahead and click OK. So what you see is that jawbone overburden and jawbone, so it values thickness, inverse distance. So we have in surface file, we have jawbone overburden thickness. However, okay, so the seam grid is not in surfaces, so I change directory of that and make sure to select surfaces. So now both of them are in surfaces. I'll go ahead and add one more grid for thickness, and what I do, I change that to polynomial. Don't select kriging because next lab we are specifically focused on kriging, so we practice it there. So change it to polynomial, and maximum triangle length is 2000. Click OK. Okay, I forgot to select strata to process. Select both of them. Click OK and separate thickness based on fit and grid. So I pick it from down here to top there, and dimensions of a cell is 50 by 50. Click OK, and what it asks is the set grid position of all other entries to new position. So you go ahead and click yes, and so we have jawbone overburden, but I add a poly to its name, so then I know it is polynomial. So go ahead and save. Click OK. So now you have inverse distance and polynomial. So you can change directory of the second one to surfaces, which is our coseam. Click OK, and its name also, you can double click on that and add a poly into that. If not, you can click on this 3 dots at the end and rewrite the name. So it is jawbone underline THK underline poly, and then I'll save. Next is I want to add base of least square. So it's power of 2, so I don't change power, I don't change search radius. So select both overburden and jawbone strata, and click separate thickness based on feet. Click OK and pick the grid position and 50 by 50. Click OK and click yes. So now you click OK. Here is base of least square. What I do, I select on the directory here, change the name it to jawbone underline OB underline THK underline LQ, stands for least. So if the program was paused for a minute, so I just repeat it. I renamed the overburden file to jawbone OB THK underline least square LQ, and same thing for the cold strata to jawbone underline THK underline LQ. And I save this one. Next I'm going to add grid based on ABOS. So ABOS is going to be more accurate than the rest of them, and this method is, I can show it to you here. So it's based on mathematical method that smooth the surface over and over in different iterations. So then you see that the surface gets smoother and smoother. In this picture, you see the effect of smoothing in ABOS method. So the first is minimum curvature, the second is the surface based on Kriging, which is accurate because it's statistical, but it takes long time to process for large area and large amount of data. Next is similar, but it's smoothed. So that is ABOS method that we are going to use here. Okay, go back to our data. So we have it here. So I select ABOS, and then you define an accuracy, and based on that accuracy, you repeat the calculation until you get to that accuracy. So I don't change any default value, I just go ahead and select stratas and separate thickness fit, click OK and set grid position, pick it bottom to top right corner, dimensions of the cell is 50 by 50, click OK and yes, choose grid file. So it is, I will change that later, so click OK. Here in the last one, so that the 7th and 8th rows that we have ABOS method, so click on directory, and so it's in surfaces, so you can now write jawbone underline OB underline THK, which stands for thickness, and underline ABOS. Click save, and the next one is going to be jawbone underline THK, which stands for thickness again, and underline ABOS. Go ahead, click save, and then we can save the setups as well. So click on save here, and so it's autogrid.run, this save. So if you want to rename it, you can go and change it in save it. So I'm fine here, and then you can click on make grids. So now it takes longer time because we have different setups. Then click OK after completion. Alright, now you can exit this. So we can now, you can see the grids of thickness in view, 3D viewer and surface file. So if I, for example, check jawbone thickness, not overburden, for least square, I go ahead, click and add on and wait to see here. Alright, so what I see here is, let me select color by elevation. So I see different lines here which is not accurate, and I don't have any data there. Why is it like that? Because I can't minimize. Okay, because drill holes are aligned on north west to southeast side of the data, and then we have the area, and also we have some drill holes on northeast corner. However, there is no drill hole. To determine or model this area in southwest corner, so then the quality of interpolation is less or 0. It means that we don't have any data. So you can look at it like here, but best thing to look at data are contours. So thickness contours are lines that each line define thickness of the layer. So we can go ahead and have that, but before we can go to model and add at least one more surface to compare. For example, jawbone thickness ABOS, and if I turn off the least square one, so here it's smoother and also is in whole area. So that is because this calculation will repeat the method over and over until it gets to the certain accuracy that we want. So that is what it means, and how it looks like compared to the other one, which has sharp edges or sharp color. So if I also turn a vertical scale on, because it's thickness, so we don't have any vertical scale. Sorry about that. So we go ahead and look at these data in contours. So X out of this. Next is to create contours.